This video is on solving systems of equation inequalities using quadratics and linear quadratics. We're going to be focusing on the quadratic inequalities on this one. Graphing an inequality in two variables. The inequality type that we're going to focus on for this one is, we're just going to talk about the x and x squared and negative x squared. So we're going to deal with y equals x squared and y equals x squared and y equals negative x squared. We're going to talk about less than or greater than for both x squared and negative x squared, just to show you how it is graphed. So if it's y is less than positive x squared, y is greater than positive x squared, y is less than negative x squared, and y is greater than negative x squared. Now in this case, it is supposed to be a dotted line, but just to show you the way it's going to be graphed, I'm not going to do the dotted, it's just showing you the shading part. So I want a positive x squared, so I'm just going to graph just a positive x squared, positive parabola for these two, positive parabola. But for this one I have a negative parabola, so I need to have a parabola that goes downwards. And now what I'm going to focus on is the shading and which direction it will shade. So yes, these are supposed to be dotted because they are just less than, greater than, less than, greater than. There's no equal to part. So if it should have been an equal to part to be solid. So when you're shading with quadratics, it's very similar to shading linear. This one says less than. So if I take my vertex and it says less than, that means below. So I want to actually shade below the parabola. So I'm going to draw an arrow down, which in this case there's two locations. It's either inside the parabola or on the outside of the parabola. If I take my vertex and it says to basically shade down because it's less than, I'm going to shade outside of the parabola. So my shading is actually outside of the parabola. I'm going to shade all of the things outside the parabola. For y is greater than x squared, so again, if I take my vertex, it says greater than. Greater than means to go up. So I'm going to go up. Now, this line that I just drew is actually inside the parabola, so my shading is inside the parabola. All inside the parabola. So we're still going to follow the same information, so less than negative x squared. So if I take my vertex, less than still tells us that we're supposed to shade down. So if I shade down, I'm going inside the parabola. So inside the parabola is where I shade for this less than negative x squared. For the y is greater than negative x squared, so again, on my vertex, greater than means to shade up. So I want to go up. This is on the outside of the parabola. So I'm going to shade everything on the outside of the parabola. This is just to help you know where the shading will be located with any type of quadratics. If it's less than a positive, it's going to be on the outside. Greater than a positive, it's going to be on the inside. Less than a negative, inside. Greater than a negative is going to be on the outside. So it's just flipped. So systems of quadratic inequalities is when we have two quadratics, or a quadratic and a linear, and we're going to graph them and we're going to shade them. We want solution possibilities is the intersecting regions, is where we have the overlapping shaded regions is a solution. That's the stuff that we will highlight. Then there are separate regions where no solution exists, so no shading overlaps. We want to make sure that the inequalities are solved for y. Then we want to graph both functions, and we'll use a table of coordinates. We'll do a dotted or solid lines, depending. We'll shade each inequality in the proper direction, and then we'll shade the overlapping region. So on this first one, we have y is greater than or equal to x squared minus x minus 2. This is a parabola. I'm going to do this in this light blue color. This is going to be a solid inequality. I need to get a table of coordinates. So if I go to my calculator, I want to go to my y equals, type in just x squared minus x minus 2. And I want to go to zoom 6, which is zoom standard. It looks like my vertex is around the positive 1, close to it. So if I go to my table, so second graph, I go to a positive 1 here. This value is a mirror image of this one. That tells me that my vertex is actually in between something. So if I scroll up a little bit, I have mirror images of -2, -2, 0, 0, 4, 4, and I'll have 10, 10. So my vertex is actually in between here. So my vertex is probably at 0.5, and then it's going to be below -2. So I'm not going to actually find my vertex, but I'm going to write out these table of coordinates so I can graph them. So I'll have the -1, 0. Type it. I'll do the -1, the 0, 1, 2, and 3. So I have -1 is at 0, -2, -2, 0, and 4. So 0, -2, -2, 0, and 4. And there's obviously more coordinates that we can graph. So we have -1, 0, 0, -2, 1, -2, 2, 0, 3, 4. And because I can do a mirror image, so I know it's going to be at -2, 4 as well. And then the next one was going to be at 4, 10. So I'll graph 4, 10 as well, just to give as many coordinates as I can. So I can also do the mirror image. It's going to be at -3, 10. Now my vertex, I can't draw a line down here. My vertex will go underneath it. So my solid, it is a solid one. So I'm going to go ahead and connect these points over here. Now down here at my vertex, I'm not going to go straight across. I am going to go down and then back up some, because I do know my vertex is below that. And it does have to look like a parabola, which has a curve at the bottom. I'm not going to shade yet, just because I want to graph my other function. This other function is a line, -x plus 2. I don't need to get coordinates for that because it's just a line. I will go to my y-intercept of 2. My slope is down 1, right 1. Down 1, right 1. I'm going to do as many coordinates as I can with that. Down 1, right 1. And then I can go up 1, left 1. Now this one is going to be dotted. This was my pink one. This is dotted. So I'm going to connect every other coordinate just to make it dashed. Dashed or dotted, whichever one you want to call it. Now is when I can shade them. I have all of the graphs. I've done the dotted or solid lines. Now I can shade them. So for my blue, for my light blue, it says greater than. Now it is an inequality. It's greater than and it's a positive. So it's greater than and a positive. I should shade inside the parabola. Just to make sure, if I take my vertex and it says greater than, it's shading up would be inside the parabola. So that is correct. I'm going to shade inside the blue parabola. Then we're going to shade the pink. Now, the pink, since it's a line, we're going to make sure we understand if it's greater than or less than. So it is greater than the line. So any point on this line, I need to shade up from it. So I shade up. That tells us that this half of the graph is what needs to be shaded. So I'm going to shade this half of the graph all the way through. Now the overlap, the intersecting regions, the ones that we're going to highlight, is where they overlap each other. Inside here I have pink, I have just pink here, I have all white down here, just blue, just pink again, but in here is where we have pink and blue. So that's where we want to highlight. So inside of here, and then along the line here, and then back along the parabola, and then everything in between. That's actually the solution. it is an x and a y. We already have our count by, it's already scaled. This last example is a quadratic and another quadratic. So we will have two tables here. So for our y equals, I'm going to type in x squared plus 2x minus 5, x squared plus 2x minus 5. I'm going to look at the graph to see where my vertex is roughly. Looks like it's about at -1. The x value of about -1. So second graph. My -1 is right here. And as you can see on the y value, I have mirror images around that -6, but -6 is not repeated. That tells us that this is our vertex. So -1, -6 is going to be in the middle of our chart. -1, -6. That means I'm going to have 0 and 1 here. Then I'll have -2 and -3 here. So in the coordinates, so we'll have -5, -2. -5 and -2, and then these will be mirrors. So -5 and then -2 again. There are more, so we can also graph the 2, 3 and 3, 10. So to graph this, -3, -2, -2, -5, -1, -6, 0, -5, and then 1, -2. But again, we can also graph the 2, 3, 2, 3, which means I have a mirror of that, and then 3, 10, which I have a mirror of that as well. I'm not going to go to -1, this is our axis symmetry, so 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3, 4. Mirror images. Now this one, this quadratic, is going to be a dotted quadratic. So we got to be extra careful about this. Dotted. Just make sure you, as you draw your parabola, it is, try and make it dotted, but clear enough that you see that it is a parabola. There's our first dotted parabola. And now the second one is y is greater than or equal to -x squared plus 4. So again, we're going to go into our calculator, -x squared plus 4. We're going to look at our graph, which looks like the vertex is at 0, 4 table, 0, 4, and then we have mirror images around it. So that tells us that 0, 4 is our vertex. That 0, 4 will be in the middle. So we'll have 1, 2 on this side, and then -1, -2 on this side. So at 1, it's at 3. 2 is at 0. So 3, 0. 3, then 0. That means we'll also have 3, then 0 on this side as well. And then we also have 3, -5, which we can graph. So 3, -5 is another coordinate we can graph. So 0, 4. 1, 3, 2, 0, and I'll do the mirror images of those as well, which is -1, 3, -2, 0. There's also a 3, -5. I want as many points as I can get. 3, -5 right here. Then 1, 2, 1, 2, 3, 1, 2, 3 for my mirror image. So I have those points plotted, and it's going to be a solid line because it's greater than or equal to, so this is solid. It's a little bit easier to draw that. And now we are going to shade them. So again, this is an X and a Y. We're going to shade. So for the blue, I want less than. So if a less than a positive, so less than a positive is on the outside. So I know I'm going to shade on the outside of the blue. Outside of the blue. All outside of the blue. Even if it's hitting the pink, it does not matter right now. We're just hitting all the outside of the blue. Okay. Then we want greater than a negative quadratic. So if we come up here, greater than a negative is going to be on the outside of the pink. So on the pink, we're going to do the outside of this. So all the way outside of this pink. All of this. All of this pink. So the question is, where do they overlap? Down in here, this is only blue. This is no solution at all. This inside of here is only pink. They actually overlap on the outsides, both of the outsides. So our highlight actually goes on the entire outside of both of these parabolas. So I'm just going to basically highlight around the parabola and then go outwards. I'll do the same thing for the other side. I'm going to highlight around the parabola basically, and now I'm going to go outwards. Because all of this is part of the solution set. This is solving quadratic inequalities with quadratic linear, a system, and quadratic.